Okay, welcome to section 1.1 part 3, where we're going to look at defining subtraction and division. Alright, and the reason we want to know how to define subtraction and division is because if you want to apply one of your properties that we just learned, whether it's multiplication or addition, you cannot really apply those properties if you see subtraction or division in the problem. So basically what the definition of subtraction is going to do is it's going to change, and I'll put a little note here, it's going to change subtraction to addition. And we want to change subtraction to addition so then we can use our property of addition, whether it's commutative or associative property of addition. Alright, you need to have all addition there. So there's a simple formula for it, and so we can see the formula is, here I'll keep it in red actually, try and put formulas in red here. So a minus b, we've got subtraction. So we want to change that subtraction to addition, so all we're going to do is add the opposite. So a minus b is the same thing as adding the opposite of b, or plus the opposite of b. Alright, so if we had, remember, a was 5 and b was 2. Right, so if we had 5 minus 2, it's the same thing as adding the opposite of 2, which is negative 2. 5 minus 2 is 3. Adding the opposite, 5 plus negative 2 is still 3. It's the same. Alright, but we are going to want this portion here. Alright, we want this portion if we're going to be using our properties of addition. Alright, so we want to make sure we're changing all subtraction to addition first. Alright, so here's a little problem. Alright, give us a little bit more space. Let's erase this. Alright, so let's say we have 6 minus 6 plus y. And if I had to use my properties, I couldn't use them because of this subtraction here. Alright, I'm going to know this is going to be equal to y, and I might have to prove that this is true. Prove that this is true. So, the first thing I'm going to want to do is make sure I have all addition. So, I'm going to change this subtraction to addition by saying 6 plus the opposite of 6 plus y. So this process that I did here is what we just learned, and that's called the definition of subtraction. So that's the first step in my proof. And then I'm going to go ahead and see, well, what property can I use? Alright, and I see I've got a 6 added to the opposite of 6. So 6 plus the opposite of 6, well, I'll slide back up. Even though it's a different video, I still have that here. Any number plus its opposite is going to equal what? 0. That's my inverse property. So I'm going to say 6 plus the opposite of 6, well, that's 0 plus y, and that's my inverse property of addition. And then lastly, I have 0 plus y. Well, anything plus 0 is just y. Alright, it's itself, right? And it didn't change, right? It's kept its identity. So that's our identity property of addition. So I just proved that this was true by using all the properties. Alright, but in order to use them, I had to make sure that everything had addition, and I used the definition of subtraction to change all subtraction in the original problem to addition. And we're going to do the same thing with division. Alright, there is no commutative property of division. It's only the commutative property of multiplication. And alright, so if you do have a problem with addition, you're going to want to change all those, or if you do have a problem with division, you're going to want to change all the division signs to multiplication first. Alright, so that is our definition of division. got to get rid of all the division signs. So we're going to change division to multiplication. So let's say we have A divided by B. Well, A divided by B, I'm going to change division to multiply, so I'm going to multiply by the reciprocal. So it's going to become A times, what's the reciprocal of B? It's 1 over B. So you change division to multiplication, and then you change whatever comes after the division sign, you flip it, all right, and you put down the reciprocal, right? And it's 1 over B because this is B over 1. So if we had a problem here, all right, such as 5 and 2 still, so 5 divided by 2 is equal to the same thing as 5 times 1 divided by 2. Well, 5 divided by 2, that doesn't go evenly, so we're going to keep that in fraction form. It's 5 halves. Right, multiplying fractions, just multiply across. 5 times 1 is 5. 1 times 2 is 2. We can see 5 halves and 5 halves. It's the same. So let's take a look at a problem that involves division. All right, and see if we can prove it. So we've got, let's say, C divided by 2 times 12. And I'm going to tell you this problem is going to equal 6C. So we want to prove that it equals 6C. So in order for me to do this, remember, you have to have all multiplication. I've got multiplication here, but I've got division here. So the first thing I need to do is get rid of that division, put it into multiplication. So I'm going to rewrite this as C times 1 over 2 times 12. And that process was my definition of division. Alright, so now I can see I've got associative property here. Alright, I've got grouping. Doesn't matter how it's grouped. Alright, so I'm going to multiply what's in parentheses first. So C times 1/2, remember C is over 1, so multiply straight across. C times 1 is C, 1 times 2 is 2. And that's my associative property. Of multiplication. Alright, so now all I see here is I have to multiply or divide, right? We can cross simplify here. 2 goes into 12 6 times. And we've got 2 goes into itself once. So I've got C times 6. And that's just basically a simplification process. Simplify. And then C times 6 isn't the exact same as 6 times C or 6C because the letters and numbers are flipped. So what's that property called where I can flip them? It doesn't matter the order that the numbers come in. Alright, that's my commutative property. Or commutative, sorry. And so if I switch the order, I end up getting 6C, which is exactly what I needed. Alright, so there is using the definition of subtraction and division to prove operations using our properties.